Okay, so this required practical is about titration and using titration to neutralise a substance accurately. So the learning outcome is to use titration to determine the volume of acid needed to completely react with an alkali. So, link to the Caboodle book, pages 80, 81. Some really good stuff in there, all about the pH scale, a bit of revision for you if you're feeling a bit rusty on your pHs. And today we're going to look at specifically the equipment. Now, this isn't a piece of equipment that we rock out very often because it's quite expensive, a bit of a pain to clean, and personally I'm too short to use it, but you'll see why in a second. So here is my equipment list, and here's a picture of all my bits of equipment, and here is another picture of all my bits of equipment. So I'm not sure what that picture shows, but we'll move on, shall we? So, what are the variables in this experiment? So let's start off with my independent variable. It's the concentration of alkali. The dependent variable will be the concentration of acid. The control will be the amount of indicator added and the amount of acid added each time. Also, why should the acid be added 1 drop at a time? Think about that. Why is that important? And this improves the accuracy. It will also increase the chance of obtaining a true value, as the resolution will be down to 1 drop. So, risk assessment. We're using acids and alkalis, so think about this. Make sure the top of the burette is at eye level when pouring the acid. The acid-base indicators are toxic, and sodium hydroxide is an irritant, so no bathing in it, guys, or drinking it. Care should be taken with them both. Goggles must be worn during this practical, and if any chemicals get spilt on your hands or in your eyes, they must be washed out with copious amounts of water, and the teacher must be informed immediately. If they're ingested, I'd question what you're up to, but medical treatment must be sought immediately. Okay? There has been people that have been that daft. So, method. Again, here is my equipment all set up. And you can see the burette is like a long, thin glass tube, which has a tap at the bottom. And if you've ever used one, the scale seems to go the wrong way. So, just be aware of that. Okay, well, if you get that in the exam and they give you a picture of the scale, check which direction it's going in, guys. Use the pipette and the pipette filler to add 25 centimetres cubed of alkali to the clean conical flask at the bottom. Add a few drops of indicator. Okay, now what we said about adding that being a control variable, you'd need to add the same to each one. So make your few a nice number. Fill the burette with acid and note the starting volume. Add the acid to the burette to the alkali. Now you do this by opening the tap and letting one drop through at a time and swirling it to mix to make sure it's all reacted. Stop adding the acid when the end point is reached, and this is the appropriate colour change depending on which indicator you used. In this picture we've got phenolphthalein, okay, but it could be universal indicator. Repeat steps 1 and 5 until you get concordant readings, and that means the same method works for adding alkali acid. Oh, what? That doesn't make any sense. Concordant means that you get 3 readings within similar proximity if they're really nice and close. Now, the same method works for adding alkali to acid. You just swap them around. It doesn't matter which way round they go. You can put either one in the burette. Okay? So, my results. You need to do 3, and you need to make sure that you calculate your mean. Okay, you only calculate the mean for the last one. So this trial one where it says first reading, that is the reading that you initially start with the acid. The second reading is what you'd measure on the burette when you've added it and it's completed and it's neutralised it. You then calculate the difference between the first and the second, and that would give you a final titer. You do that 3 times and then calculate your mean. So we could improve the accuracy of our results by repeating it, okay? And we could improve the accuracy of our results by also making sure we don't involve something called parallax error. So by making sure our eye is at eye level to where the acid is, or the alkali is in the burette, right? We also should try and make sure that we repeat any results. So if you've got 2 concurrent results and then you've got a third one which was way off, then you need to take another reading, because actually you need to discount that anomalous result and get 3 concurrent results. If your results are concurrent but they're still way off, then you need to repeat more times. Repeating means reliable, okay?